Hi again, thanks for coming back to watch episode 2. The last time we got the app working, but it only really said yes when you asked it a question. So today we're going to have a look at, at the end of today, when we press the button, it's going to give us a different answer each time, or a random answer each time. It'll not be a different one each time because there might not be that many answers to give. Here we are, and this is just how we left it last time. So we've got the answer label and the shake button function, which just now sets the text to yes. That's what this button here does. And then we've also got this answer label.text setting the label to nothing when we open it up, instead of saying label like it says there. We don't want that. So the first thing I wanted to talk about today is variables and constants. Variables and constants you'll use all the time. It's a way of storing data either permanently or temporarily, sort of permanently or temporarily in a application. So if we just have a look in the view.load function, a variable, by the way, is a use. So if you wanted to store, say, a piece of text that said this is the label, let's just go for that, this is the label, right? You put that there. So if you want to store that in the program, you can't just write it like that, you need to store it in something. So you give it a name, for example, piece of text, piece of text, and you make the piece of text variable, in this case, equal to this is the label. But piece of text here doesn't mean anything, it's just a sort of reference. That's why we're getting this error. So what we need to do is make it a variable, and to do that in Swift you type the word var in front of it. Now once you've got something in a variable like that, you can go and use it elsewhere. So var piece of text equals this is the label. So what that's doing, a variable, by the way, can be any data type. A data type is like a string. That's an interesting bit of here. A string, a number, or an integer, an array, which we're going to look at later. Anything, basically. You can have anything that you can do can pretty much be a variable or a constant. So a constant, so if you make something a variable, it sort of implies that you want to change that. So the way that the phone stores the data in its memory is different to how it would store a constant. So if you store it as a constant, it stores it sort of just in a place where it doesn't need to access it to change it very often, so it makes it easier on the memory handling to deal with it. Constants are dealt with this keyword, which is let. So we could say let title equal Magic 8 Ball, because the title's never going to change. It's always going to be an app called Magic 8 Ball. So it wouldn't make much sense to make that a variable. This is about changing it once the application's running. So at this stage, obviously, we can change anything because it's not running just now. Once it's running, if you tried to change that constant there, title, if you tried to change that, it would give you an error, or it wouldn't compile the code if you had said later on allow this to be changed anyway. But the variable one would. This variable one, that you can change that once the program's running. So let's get rid of them because we don't need them. Up here we could say here, declare a variable, call it an answer, and then make it equal to yes. Not that one. Yes. By the way, when you're making a variable, the Swift language automatically assumes what type of variable it's going to be, whether it's going to be a string variable or an integer variable or array variable or whatever. The language assumes it. So here you've said make this variable and create and you're initializing it with the string yes. If you change that to a 0, it's going to initialize it as an integer variable, and if you did it with something else, it would make it something else. So we're going to say yes. So if we ever tried to say variable and answer equals some other type of data, it might give us an error. If we tried to make it an integer, it would cause an error. So here we can say var and answer equals yes, and then we say answer label.text equals an answer. And see it says there string, and then we can hit enter, and that's all perfectly fine. It likes that. But I will say here that this warning, you get these yellow ones, they're not so important, but the yellow ones are warnings, and it's basically saying you're never changing this in your code, so why don't you make it a constant? Well, I don't want to. I want to keep it as a variable, so just press escape. Because it'll still work with that, it's just telling you it would be better if you did it the other way, because you're never changing it. So let's run this and see if it works. So we've taken the answer out of there at the text bit, taken the answer out of here in the label, and then we've put it into this variable, and then put the variable into the text property instead. So let's see if that worked. Oh, it's loading the simulator from nothing. So here's a wee hint for you. You see the simulator's massive there. We don't need it to be that big. So if you go in here and go to where is it again? Window, scale, and then just bump that down, make it 50%. And here we go, Magic 8 Ball app has loaded for the second or third time or something. If we hit shake, then now the text from the variable should be, see here, we're saying when we press shake, store this text in this variable, and then it does it all in order. So, and then make the answer label equal to the variable, whatever it says in the variable. So then if we go into the simulator again and press the button, it's going to do both of those things, and then put yes back in there. So we'll stop that again, keep the simulator running so it's quicker for next time. So now we'll get rid of that. Now we want to have the opportunity or the option for more answers, because just having a Magic 8 Ball that says yes is a bit optimistic, and it's never, you're going to end up disappointed quite a lot, unless you wanted to know a no answer, or you wanted, I don't know. Anyway, it's going to be confusing, and it's not a Magic 8 Ball if it just says yes. It's more like a yes ball, and we're not making a yes ball app. So variable, let's call this answers, but it's going to be an array. An array is basically a list of information, so you can have as many things as you want in it. We're just going to have a few answers, so we'll call it answers array in the camel case way, and then that equals, then the way you define an array is you do square brackets like that. But what we're going to do is we're going to initialize it here with the type that we're going to use. So we're going to say yes, and that's put a string into the array. It's just one object, so pointless it being in an array at this point. We're still getting an error down here because an answer is nothing just now, so we'll just comment that out. To comment something out, you just do / like that. So it's still saying it's an error, right? Well, let's just delete it then. Shut your face about it. So now we're getting this. You get these errors. You have to just ignore these after a while. It's basically saying that this is never used. So it's never used. So you can do this to fix it. But it is going to be used. And if we go now, answers array dot append, and then we can add no into it, and that's perfectly fine. Now the array, when this runs, the array will have two things in it rather than just the one that it had before. But in here we'll add some more in as well. So you do this, just do a wee comma and then add the rest of them in. So maybe yes, maybe, of course, what else? Don't, have one of them. Count on it. Yes, maybe, of course, don't count on it. Let's go for a hell yeah. Can I get a hell yeah? Let's go for a as well. And maybe we'll go for a... Why don't we go for a 9? And a... Yeah. And what about maybe a C? Oh, that's just reminding me of that Justin Bieber song. That's annoying. Forgot a comma here. See, it's saying there's an error. It's because we forgot. Let's see what the error says. We know what it is. Expected comma separator. So Swift is really good. It helps you fix the code when you screw it up. You just come and press that button. Most of the time it's got the right answer. So we've got all these, and then we've also got append no as well. So we'll see how that works, right? So when we press the button, it's going to put all the stuff into the array. Whether or not when we press the button is the right time to do that is up for debate. We'll see about that soon. So now what we want to do is when we press the button, it's going to fill the array. Then we wanted to choose a random option out of the array and assign that to the label. So the way we do that is first we get the random number. So now we're going to go a new variable called random number, and we're going to set that to a random number by using this random number generator, if you like, called arc for random. And then it wants a number which is a uint32. A uint32 is an unsigned integer, which is 32 bits. Unsigned means it can't go negative, but it goes, because it doesn't go negative, it goes double into the positive. So integers go half the way of an unsigned integer up, and then they can go half the way down again, so you get plenty of range, but this only wants an unsigned integer 32 value. And in here we need to put in what the upper bound is. So the upper bound of this number is going to be 10, because that's how many items we've got. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yes, right. And then what's the error? Initialization of random. It's never used, right? That's fine. It is going to be used. Don't worry. And then we get the number. We get the whatever that random number says. We're going to use that number to get the item from the array which corresponds to that number. We're going to put whatever comes out into the answer label.text. So we say answer label.text equals, and then we want it to equal an item from the answers array, and the item that we want to set it to is whatever item is in the place of the random number. So if we say in here answers array random number, which makes sense, but I'll moan about it because it doesn't like the number that this spits out. So when you do an arc for random, it gives you a unsigned integer, and this only like, and the referencing in an array only likes integer values. So what we do there is we change what we're going to get out of this to an int. So it takes what it gets out and converts it to an int, and then it'll stop moaning about that, and it's going to build, right? So now if we run the application, it built fine, so that's good, and we'll see what it comes out with when we press the button. Shake. Alright, so the label's not big enough. Let's just shake it a few times. No, C, yes, 9, and then some other ones that are too small to read. Right, good, good. That's different answers. So now we need to make a couple of adjustments. Let's change the size of the label so that we can see it. Get rid of that. So we'll make it as big as it'll go. There we go. And we'll also, why don't we, while we're here, you can go in here and just like a word processor, change how things look. So that's going to be in the centre. So we need to change that, and then we'll give it a bash again before we do anything else. There's one more thing we need to do because just to tidy things up. So now if we shake it, don't count on it, we're getting all the answers. Let's see, we're going to get a yeah or a no. Yeah, we're getting no, and we added no in separately, so we know that's working. We're getting a C, we're getting a we're getting another C, a 9, a C. Don't count on it, right? Good. Now we can stop that, right? So that's looking a bit better. It's working a bit better anyway. Then if we go now, the problem here is this 10. Because if I add another one in to that array, if I think, well, maybe I want to put a, I don't know, maybe if I wanted to say I don't know, if I go in here and say I don't know, maybe put a space in, then when it's never going to get to the end of the array, because it can only look up to, you'll never get a no now, because it compiles this array and then it adds in the no after. Or if the no was still in the list, it would still be number 11. So it will never get to that. So we need to, does that make sense, right? So if we run it now, you're never going to get number 11 because you've only told it to do a random number up to 10, and you've done that manually. So now if we run the application and shake it, we're never going to see no in here. We'll see all those other ones. We'll see I don't know as well. That should come up, hopefully. Doesn't count on that. Oh, not seen I don't know yet. There we go, that was I don't know, but we're not going to see no. We're going to press that all day and we'll never see no, in English anyway. So what we do to stop that is we could put an 11 in there, and then when we came back the next time and put in another one, we'd have to change it to 12. So we don't really want that, that's not clever. So if we take this out, so we're looking for a random number up to 10, but what we're actually looking for is a random number up to the amount of items in that array, and there's a special what's it called, a special function of that array, of the array type that you can use, which is called the count, right? So if we go answers array dot count, and what answers array dot count does is it returns an integer value for the amount of things in the array, and now it's going to moan its face off again because now we've got the opposite problem. So what we've done, right, before I fix it I'll show you, right, so we had to change this to an integer value so that we could use the integer value to look in the array. But now that we've put the array count in, which is returned as an integer value, the arc4random function doesn't like it because it only likes uint32. So what it's saying is you need to fix this. You need to take your array count, convert it to a uint32 so that it can be used in the arc4random, and then you need to convert it back to an integer if you want to use it in this array, in this function down here. So if we click that, it'll tell us, oh, not breakpoints, we're not doing that today. How do we get rid of it? Delete. So if we click on that, it says replace answers array.count with uint32, and then in brackets answers array.count. And that'll fix it. And now it'll work fine, and we'll get no this time because it's going to build the array, then it's going to put a count into this random number generator. When it runs this code to generate the random number, it'll be always looking for the however many items are in the array. So we should see no in here. Whether or not we see it quickly is different, so we'll just keep going until we see it. There we go, that was it. It's there, you've seen it, everything works now. That was quite a long one, explaining that. So next time what we'll look at is abstraction. So we need to get, we don't want everything that's happening there to necessarily happen when you press the button. We want to make that something that happens elsewhere. So when you press the button, it'll go somewhere else to get it. It's like sort of like, you don't want to always make a pizza at home. Sometimes you want to phone somebody up and ask them to give you a pizza. So what we're going to do next time is we're going to change this so that when you press the button, it phones up somebody else and asks them to give you an answer, and then you just put the answer on screen. But it doesn't take very long, and it doesn't cost anything, which is brilliant. Also doesn't taste very good either, so that's fine. So that's quite good. We've learned today about arrays, variables, constants. We've learned about appending things to an array and random numbers. And this is a really complex bit of nonsense here. It's not like advanced programming or anything, but it's definitely could be tidied up. We'll maybe tidy that up in a future episode. But for now, we're done there, and we also made this bigger as well. That was a good point. So yeah, come back next week and we'll look at abstracting some of that out to make the code a bit cleaner and a bit easier to read and deal with. And that's all for today. Thank you for watching, and I'll see you next time.